Ceramic vacuum tubes, often called metal ceramic tubes, are specialized electron tubes that use advanced ceramics, typically alumina or beryllium oxide, instead of glass for their outer envelope and internal insulating structures. Because they look more like machined metal engine parts than traditional glowing glass bulbs, they are often unrecognizable as vacuum tubes to the untrained eye. While glass tubes are excellent for low power audio and radio applications, they hit severe physical limitations when pushed to handle massive amounts of power or extreme frequencies. Ceramic tubes are developed to solve these bottlenecks. Extreme heat tolerance. Glass softens and melts at high temperatures, and it can release trapped gases that destroy the internal vacuum. Ceramics can withstand temperatures well over 600 degrees centigrade. This allows the tube to be baked out at much higher temperatures during manufacturing, creating a harder vacuum, and lets it run significantly hotter during operation. Massive power in a small size. Because ceramic can handle the heat, these tubes are usually mated with heavy copper or metal anodes featuring ribbed cooling fins. When forced air is blown through these fins, a ceramic tube the size of a coffee cup can safely dissipate thousands of watts of heat. High frequency performance. To amplify high frequency signals like UHF or microwaves, the internal elements of a tube, the cathode, grid and anode, must be placed incredibly close together to reduce the time it takes electrons to travel between them. Ceramic can be machined to microscopic rigid tolerances that glass simply cannot hold, reducing parasitic capacitance and allowing operation into the gigahertz range. Mechanical durability. Ceramic metal seals are incredibly robust. These tubes can survive mechanical shock, vibration, and G-forces that would instantly shatter a glass tube, making them ideal for aviation and military use. Because they are expensive to manufacture, ceramic vacuum tubes are reserved for applications requiring massive power output, extreme frequencies, or both. Broadcast transmitters. The final amplifier stages in high power FM radio and television broadcast towers still frequently rely on large ceramic tetrodes or klystrons. Radar and military RF. High power radar installations, electronic warfare jamming pods, and missile systems use them for their sheer power density and immunity to electromagnetic pulses. Medical equipment. The core of a CT scanner or medical X-ray machine relies on a specialized metal ceramic tube to generate high energy X-rays reliably. Industrial heating. Used in dielectric and induction heating equipment like for melting metals, curing plastics, or drying wood on an industrial scale.